This is Wills and Trusts, Chapter 2 on Intestacy, Part 3. Just a quick review. We said testacy is when a decedent leaves a will, and that will disposes of all of the decedent's property. We also said that at times a decedent can leave a will that disposes of only part of their probate estate, and the part of the estate that isn't disposed of the will passes by intestacy. It could also be the case that the decedent leaves no will, and in that case, the probate estate passes through intestacy as well. So no will or partial. Intestacy just supplies the default rules. And in all states, intestacy favors the spouse, then any issue. If there are no issue, then the parents of the decedent. If the parents have predeceased the decedent, then it goes to the collaterals. And finally, it goes to the remote kin. If there are no remote kin, then the property passes to the state. We also said that even when there's a surviving spouse, if there are also issues, then that surviving spouse will likely have to share in the estate with the remaining issue. And how much that surviving spouse shares depends on a few different factors. If you open up your book, take a look at figure 2.1 on page 69. The UPC outlines the percent of share that goes to the surviving spouse if there are issues, as well as the various divisions that occur depending on the mix of relatives that are still alive at the time of the deceased's death. Why don't we do a quick practice problem to review this material? Suppose that Howard is married to Wendy. And Wendy and Howard have two children that are from their marriage. Their children are Anne and Billy. Before getting married to Howard, Wendy was married to Tom. And from that marriage, she had a child by the name of Zane. Now let's say Howard dies intestate. I'd like you to apply UPC 2-102 and tell me, what will Wendy's share be? What will Wendy's share be? Now, assume that the estate that Howard left, it's worth $1 million. If you take a look at UPC 2-1023 and apply that, you'll realize that Wendy's share is $225 plus half of the remaining assets. Well, if we have 1 million and we subtract 225 from that, we get 775,000. Then we take half of that, and that gives us $387,500. So that is Wendy's share. What happens to the other $387,500? It goes to Ann and Billy, and it's divided between them equally. Zane does not get anything because Zane is not Howard's issue. So far, we have covered how a surviving spouse's share is determined. I'd like to move on to discuss how the shares of the children are determined, or the shares of the issue are determined, particularly when one of those children has predeceased the decedent. So when one of the children has predeceased the decedent. When a child predeceases the decedent, there are three options in how to divide the shares, and we discussed them in a previous video, but we're going to go over some examples now. So the first option is the per stirpes, or the English per stirpes. The second is per capita by representation, but it's also referred to as modern per stirpes. And the third is per capita. At each generation. Let's do some examples. All right, in this example, B has predeceased A, and C has predeceased A. Then A dies. I'd like you to first apply the English per stirpes method to determine what the shares are for D, E, and F. For the English per stirpes, we divide first at the first generation that the decedent has issue, regardless of whether or not these issue are living. So we would divide the estate first at this first level here. And then if one or more of the decedent's children predecease them, in this case we have two of their children predecease them, then we drop that share to that child's surviving issue. So in this case, D would get 1/2, E would get 1/4, and F would get 1/4. All right. E and F get 1/4 because we're dividing that half that we dropped down into 2, and half divided by half is 1/4. Right, moving on, I would like you to apply the per capita with representation approach. For the per capita approach, we divide at the first generation where there is a live taker. That means we would skip this generation because both of the issue have passed away. They've predeceased the decedent. So we don't divide until we get down here. And so since there are 3 surviving issue at this level, we divide it by 1/3. So if we use per capita with representation, D would get 1/3, E would get 1/3, and F would get 1/3. All right, now I'd like you to apply the per capita at each generation method. If we apply the per capita at each generation method, we divide at the first generation with a live taker. So again, here we would skip this generation because there are no living takers. And so we would drop down and divide at this level first. And then we would pool dropped shares. Here that's not going to be relevant because everybody's alive at this level. So we would get the same results that we would get with per capita with representation. Let's do another problem. And by the way, you can find this problem on page 82 of your book. In this scenario, A has 3 children, B, C, and D. B has 1 child, E. C has 2 children, F and G. And D does not have any children. B and C have predeceased A. So first, I'd like you to apply the English per Stirpes method and tell me how the shares would be distributed. Okay. For English per Stirpes, we divide at the first generation that there are issues. So that would be this generation here. So there are 3 children. We would divide the estate by a third. But then for the predeceased children, we would drop the share to that child's survivors. So here, that means E would get 1/3. Means F and G would split this 1/3 here. So again, we divide by 2. That means F gets 1/6, G gets 1/6, and D gets the third. So that was the English per Stirpes method. What about the per capita with representation method? How would the shares be distributed for the per capita with representation method? So per capita with representation, we divided the first generation where there is a live taker. The first generation that there is a live taker is this generation here. So again, we would divide by 3. Then we would need to drop the shares. So E would get a third. And here, F and G would get a 1/6. And D would keep the third. Right? F and G got the 1/6 because we divided by 2 or multiplied by half. Okay. So finally, what about the per capita at each generation? How would the shares be divided? Right, for per capita at each generation, we divided the first generation with the live taker, be here. Means 1/3. Then, before we drop them, we would pool the shares together. So we were going to pool 1/3 and 1/3. That means we add them together. Gives you 2/3. Then we divide this 2/3 amongst these 3. So if we're going to divide 2/3 by 3, that's like taking 1/3, and so 2/9. That means E would be 2/9, F would be 2/9, G would be 2/9, and D would be 1/3. Let's keep going. So on page 82, there's another problem, figure 2.5. Here we have A has 2 children, B and C. B has 1 child, D. C has 2 children, E and F. E has 2 children, G and H. Both B and C have predeceased A. E has also predeceased A. So let's begin by applying the English per Stirpes method. How would the shares be divided? We're dividing at the first generation where there are issues, and that'll give us half. That means D gets a half. Okay, here for the other half, we're going to have to drop it down, and we divide it by 2. So F gets a quarter. E gets a quarter, but E has predeceased A, so we drop it down again. And G and H share in this 1/4 here, so they get 1/8 each. If you're wondering why they get 1/8, again, remember we divide that by 2. Let's apply per capita with representation. How would the shares be distributed? All right, for per capita with representation, we divide at the first generation where there is a live taker, which would be this generation. We would divide it by 3 because there are 3 issue at this generation. So that means D gets a third, E would get a third, and F would get a third. But here, E has predeceased A, so we would need to drop this down, divide it by 2. G would get 1/6, E would get 1/6. All right, now finally, how about if we divided it per capita at each generation? Per capita each generation, we divide at the first generation where there is a live taker again, so that would be this generation. And here we would then pool the shares, but that is not relevant because it's just going to go straight down to G and H. We only pool the shares if there was anyone else at this generation here. So that's the case. Instead, we get 1/6 and 1/6. So as you can tell, the problems are getting a bit more complex as we go along. So let's do another one. And this is figure 2.6 on page 83 of your textbook if you want to follow along. And you have 3 children, B, C, and Z. B has 1 child, D. C has 2 children, E and F. E has 2 children, G and H. F has 1 child, I. Z has no children. All right. B has predeceased A, so has C, and so has Z. E and I, I'm sorry, just E has predeceased as well. Let's see. So if we're applying the English per stirpes rule, how would the shares be divided? Well, for English per stirpes, you divide at the first generation, regardless of whether or not there is a live taker. So if we did that here, we would end up with Z getting a third, but Z has predeceased A, and Z has no issue. So we can't drop it down, so we actually need to only divide by 2. So in this scenario, B and C would get half. Well, B has predeceased A, so his half share drops down to D. C has predeceased A, so her half share drops down as well. It is first split amongst E and F. So F would get this quarter. E has predeceased A, so this quarter gets split again for G and H when it drops down. So the answer to this question is that D gets 1/2, G gets 1/8, H gets 1/8, and F gets 1/4. You might be wondering why I didn't get anything. Well, I doesn't get anything because F is still alive. So how would this change, or would it change, if we use the per capita with representation, or what your book calls the modern per stirpes? Per capita with representation, we divide at the first generation where there is a live taker. And so that would be this generation here. That means we would divide the estate by thirds. D would get a third. This third here would drop down to G and H would share equally in that third. So they would get a 1/6 each. And F would get a third. All right, finally, if we apply per capita with each generation, how would the shares be distributed? With per capita at each generation, we also divide at the first generation where there is a live taker. That would be this generation here. So 1/3, 1/3. So D would get a third, F would get a third, and here, again, this is just going to drop down. There's no need to pool because F is still alive. So G would get 1/6, and H would get 1/6. How about we do one more? This is the granddaddy of them all. You can find this one on page 83 of your textbook, figure 2.7. In this scenario, A has 3 kids, B, C, and D. B has 2 children, E and F, and E has 1 child, K. C has 4 children, G, H, I, J. G has 1 child, L. H has 2 children, M and N. J has 1 child, O. And B, C, D, E, G, and H have all predeceased A. So then A passes away. Let's talk about how the shares will be divided. First, apply the English per Stirpies rule. How would the shares be divided? All right, applying the English per Stirpe methods, we divide at the first level where there are issues, regardless of whether or not they are living. But because D has predeceased A and D has no issue, we need to put D's shares back into the pile. And so we really then are dividing by 2 because this line has died out. So then we would drop this half, which means it's divided by 2. And we would drop this down to K. So K gets a quarter, F gets a quarter. Then we would take a look at C's line here. So we would divide 1/2 by 4. So we would get that each get 1/8. I's line is down there, so I gets 1/8. O gets nothing because J's still alive, right? So J would get 1/8. This would drop down here. L will get 1/8. Then M and N would have to split that 1/8, so that gives them 1/16. And so that is the answer. All right, what about the per capita with representation method or modern per Stirpies? How would the shares be divided? We would divide at the first generation where there is a live taker, which would be this generation here. So that means we would have 1, 2, 3, 4, 5, 6 takers, or potential takers, or lines that would take that haven't died out. So 6. So that means each line would get a 6. All right, so we have J with a 6, I with a 6. We drop this 6 down, divide it by 2 because H has predeceased, and that gives us a 12. And then we drop this 1/6 down, L gets 1/6. We drop this down, K gets 1/6, and F gets 1/6. All right, finally, the per capita at each generation. How would the shares be divided? All right, so for per capita at each generation, we divide at the first level where there is a live taker. It would be here. So again, 1/6. But we would pool together before we drop down the shares again. So let's start by circling the shares that stop at this generation. So J gets 1/6, I gets 1/6, F gets 1/6 because they are alive. Then we deal with the issue that have predeceased. That means there are 3 shares left over. So there's 3 1/6. We add them together, we get 3/6. This is what we drop down to this next level. Because K, L, M, and N are all at the same level. So we have to split it by 4. So we have 3/6. We pooled, remember we pooled these together. And remember, this doctrine cares about equality amongst the generation. We said these are all at the same generation here. So we have 3/6, and we need to divide 3/6 by 4. So we can multiply that by 1/4. Gives us 3/24, which is also equal to 1/8. So K gets 1/8, L gets 1/8, M gets 1/8, and N gets 1/8. Now that was complicated, but at least you have the video so you can rewind and watch again. And that's it for this video.